All right, everyone, let's take a look at worksheet number 3 on position time graphs. Just to remind you of a couple of things before we go over the answers to this. When we have a graph that is y versus x, and that's what it always is, right? Y-axis versus x-axis. The title of every graph is the y-axis versus the x-axis. We have two variables on that graph, two variables on every graph. One's the manipulated variable, and one's the responding variable. Which one's which? Where does the manipulated variable go? In this case, position time, would the manipulated variable be the variable that causes the change? Would that be position, or would that be time? That'd be time. Good. Yeah, that's time. Even though we're not changing time, it's what's causing the change. The change in time causes a change in position. So time would be our manipulated variable, position would be our responding variable. Some labs you have to do, not including the first one, the one that we did yesterday, you didn't have to do this for. But some labs that we have to do, we have to identify which is the manipulated or which is the responding variable. Okay, I hope through the lab you can, in your head, work through that. But if you can't, I'll always tell you to plot a graph. And I'll tell you what graph to plot. So if I say it's position versus time, you always know the manipulated variable is the second variable, and the responding variable is the first variable. The manipulated variable is on the x-axis, and the responding variable is on the y-axis. Where do the control variables go? You know what I mean by a control variable, right? The variables that have to stay the same. Where do they go on the graph? Nowhere. Why would we plot a variable that we're keeping the same the entire time? There's no point in plotting a control variable. So it's always manipulated on the x-axis, responding on the y-axis. All right, now that we have that down straight, let's look at the actual questions here, okay? Question number 1, question 1 to 6 all relate to this first graph. Number 1 says we want to determine the position of the object at 7 seconds. How do we do that? The position at 7 seconds. Where is this thing at 7 seconds? Anyone? Yeah? How'd you get that? Yep. Yep. And over. Yep. Exactly. Exactly. Listen, if you've got a position time graph and you're looking for position, or if you have a velocity time graph and you're looking for velocity, or a force time graph and you're looking for force, or a something times graph and you're looking for something, just go up and over. Always. So you're looking for here position at 7 seconds. Okay, let's go to 7 seconds. 6, ooh, this is a little tricky though. 6.4, 6 point, our intervals are kind of wacky here, right? 6.4, 6.8, 7.2, 7.6, 7 seconds would be right there, right? If we go up and over, the position is 30 meters. I'm going to make west positive. I think that's the easiest thing, isn't it? So that I've got positive 30 meters or just 30 meters would be okay. What's displacement defined as? First A. What do we define displacement as? Change in position. All right. If we know how to find position, we just did, up and over, then the change in position would be up and over again, and then subtract the two. Just find two positions and then find the change by subtracting. So the change in position, or the displacement, between 0 and 5 seconds. Well, the position at 0 seconds is 0, right? Goes through the origin there. At 5 seconds, it's 4.4, 4.8, 5.2, 5 seconds up and over. It's 30 meters as well. 30 meters, final position minus initial position is just positive 30 meters. Jay, can you see that? Yep. What's the average velocity between 0 and 5 seconds? There's two ways we can think of this, It boils down to the same thing though. In Science 10, you guys probably learned that the velocity from a position time graph is the slope of a graph. Do you remember learning that? And it is. Your teacher didn't lie to you. But I like to think of it this way. The average velocity is always the total displacement divided by the total time. What's my total displacement between 0 and 5? I just found that. It's 30 meters. My time is 5 seconds. 6 meters per second. Now, how many of you guys, when you were working on this question, were thinking slope? How do you find slope? What's the equation for slope? What is it? Rise over run? What's the rise? What's the rise in this graph? Yeah, the y-axis change in position. So in other words, the rise is delta D. The run is delta T. So if you did it as slope, and I did it as delta D over delta T, really we did the same thing, right? What's the average velocity between 0 and 9 seconds? Well, you could draw a line from 0 to 9 seconds and find its slope. Or you can just say displacement divided by time. The displacement between 0 and 9 seconds. At 9 seconds, the position is 30 minus 0 over the time is 9 seconds. 30 divided by 9 is 3.33, I think, isn't it? We're not going to worry about significant digits on graphs. Just, you said 3.3, you say 3.33, you get a mark, right? By the way, we're also not going to tick off marks for significant digits until after your first unit test. So if you're like, I don't quite get these significant figures for the other questions, don't worry about it. Just try. Like, keep practicing it as we do it, but you're not going to lose marks for it until after we do a unit test, once you become comfortable with it. What's the instantaneous velocity at 3 seconds? I got an email from somebody about this one. Question?
In your numeric response, so if we do significant digits after the unit test, how will we know what to write in numeric response? Like to a significant digit, or we just write, will it tell us?
Yeah, well, you would always know, you just do it to significant digits. Yeah, just do it to, do everything to significant digits. Even now, try. It's just that, don't worry about it if you have trouble with that. Right after the first unit test, you'll have enough practice with it by then that it'll just be old hat by then. So you won't have to worry about it. It's not a big thing, it really is. I got an email from somebody about this, instantaneous velocity at 3 seconds, or instantaneous velocity in general. Instantaneous velocity is the velocity at an instant in time, at 1 instant in time. So at 3 seconds, how fast is it moving? The temptation here is to say, well, let's go up to 3 seconds, up and over. Okay, so it's like 18 meters per second divided by 0. We can't do that. The instantaneous velocity at 3 seconds. Look, everywhere along this path here, this interval, from 0 to 5 seconds, it was moving at 6 meters per second. Everywhere. Constant velocity. So what was the velocity at 3 seconds? Same as it was everywhere else. It was constant, right? If the velocity is constant, then the velocity at every instant must be the same. So if the constant was 6, the instantaneous would be 6 everywhere along that interval. I'm not going to show any work for that. I've already done it. What's the instantaneous velocity at 8 seconds? That's a good one. Well, that's a straight line. But what does that straight line mean? That flat straight line on a position time graph. It stopped. Everywhere. It's constant. We stopped between what, 5 seconds and 9 seconds? It stopped. So what's the instantaneous at 8 seconds? What is it? 0. I don't need to show work for that one either. If it's a flat horizontal line, it's stopped. And I'm going to say the velocity is 0 meters per second. How do you guys feel about that? Good. All right, let's move on. Question number 7. Yeah.
Over flat line doesn't mean it's moving at a constant speed.
Well, it is a constant speed. But it's a constant speed of what? What's the rise on that flat line? 0. So if we go rise over run, or displacement over time, the rise is 0, the displacement is 0. So if its displacement is 0, the rise is 0, we would say the velocity is 0. So it is a constant velocity, but a constant velocity of 0. Constant velocity of 0, which the easier way to say that is just to say it's stopped, it's not moving, right? It's the same thing. If I was to ask you, what does that mean? And you were to say, it's stopped. Okay, good, that's right. If you were to say a constant velocity of 0, it would also be correct. Okay, let's look at 6. Ooh, different shape here. Different shape. Down and then up. What's the displacement between 0 and 10 seconds? Displacement is change in velocity, right? Peyton, sorry, change in position. Change in position. Peyton, do you remember how to find position on a position time graph?
Yeah, you just look.
That's right. And displacement is the change in position, right? So let's say, for this one, let's say the final position at 10 seconds is 0. Let's make west positive again. The initial position at 0 seconds is 14. So we're going to say 0 minus 14 is negative 14 meters. It's important to have a negative there, right? What does that really mean? What does the negative mean for us there?
We're going east.
Yeah, we're going east. Usually east is positive, right? But it was just convenient to make west positive here. I'm allowed to do that as long as I specify. By the way, negative 14, or you could have said just 14 east would have been fine as well. What couldn't you have said? Okay.
Negative 14 east.
Yeah, you wouldn't want to say negative 14 east because that would have meant west. That would have meant 14 west, right? So it's one or the other. It's negative 14 or it's 14 east. The displacement between 10 and 18, 18 seconds, let's go up and over. It looks like 6 minus 0. What does the positive mean there? West. West, because they define west as positive. It makes sense, right? If it's a constant velocity in the negative direction, I've got a negative displacement. A constant velocity in the positive direction, it's a positive displacement. What's the average velocity between 10 and 18? I like to think of it as d over t, right? Caden likes to think of it as the slope. But displacement divided by time, displacement is the rise, and time is the run. So however you think of it, it's the same thing. I already got the displacement though, so I'm going to go that way. 6 meters divided by the time would be 8 seconds. Positive 0.75 meters per second. And the average velocity between 0 and 18. Oh, I almost misread that. Between 0 and 18. Okay, if you're like Caden, you want to go rise over run, that's fine. Just draw a line from 0 to 18 seconds. And then find the slope of that. Or, if you do it like me, you got to really do the same thing. It's going to look different, that's all. The displacement between 0 and 18 is 6. The time is 18. Positive 0.33 meters per per second. I think that's right, isn't it? I just saw a couple frowns. Is that wrong? Is that wrong?
I had
8
8 meters.
meters? Between 0 and 18? I think it's 6. What? Sorry? Negative 8 between 0 and 18 seconds? Oh, yeah. No, you're right. Yeah, you're right. Because all those strange looking faces were because I made a mistake, not just because you have strange looking faces. That's because I made a mistake. I can tell when I made a mistake because I can see it on your faces when I make a mistake. I should do it on purpose more often, just to see who's paying attention, see who's getting this, right? Yeah, my rise is wrong, right? It's really a fall. I went from 14 down to 6, so my displacement wouldn't be 6, it would be negative 8. And negative 8 divided by 14, that would be the same as negative 4 over 9, so that would be negative 0.44 meters per second. How do you feel about that, you guys? All right, question number 11 we will not do. Question number 11 is something that we don't have to do. That's a physics 30 type thing. Not the D versus T graph, but the technique that we use for that is a physics 30 concept. Sometimes I do it in physics 20 just to expose you to it, but just because the day that we did this I wasn't here, and you always lose a little bit of time when the teacher's not here. We'll just skip that this time around since it's not necessary for us. Number 12 we will do, but we won't do quite yet because I do want to go over that graphing stuff for your lab stuff. So probably end up coming back to a question like number 12 tomorrow, but we won't skip it. We will come back to it.